Welcome to this video of module 5 of Big Data Analytics. In this module 5, first, I missed one very important topic, you only may say, the installation steps of Hive and Pig. So first we'll discuss those installation steps, then we'll shift to module 5. So let's see how to install Apache Hive in a Linux-based system. So what are the prerequisites first? We have is we have to make sure like Java is installed in the system, and once it is installed, we may check the version, like which Java version it is, whether it is 8 or 9, and then we make sure that Hadoop is also installed and configured inside the system. Now, once you are done with all this, these are the prerequisites. That means you are the must criteria. Okay, like this three should be mandatorily be present in our system. Next is installation steps. Installation steps, what you see is first we download Hive. How to download Hive? We go to the official website of Apache, and then we download Hive and which Hive, the most latest and stable version. Okay, now once you download the Hive, you have to extract all the files. So to extract all the files, again you have to get into a directory. For example, slash opt slash is the directory name, and the command is tar minus xvf apache hive xyz bin dot tar dot gz. So what is your what is xyz is nothing but the desired version, and this minus xvf is nothing but your x is nothing but your extracting the files, v is nothing but show the files being extracted, and f is nothing but which you use the used archive file. Now once you just extract this file, you have to go inside the particular directory. Once you go inside the particular directory, then you have to set the environment variables in your system. So how you set the environment variables? You have to just add a Hive bin directory to your path and set the Hive configuration, set Hive home configuration file to this dot slash bash rc dot. This is the commands you have to remember. Then export Hive home. This export path you have to apply this. Then you apply all the changes and save it. Once you are done, you have to configure the Hive. How you configure the Hive? Again, you have to open the Hive's metastore. Once you open the metastore, then again you have to make a directory with with hyphen p opt hyphen Hive metastore. Once you are done with this, you have to configure the site.xml file. What will you in your site.xml file? There is an XML file will be present where this command set in java.do.option connection URL, where you are just establishing connection, and then you are declaring like where the path and all is declared in our for this one for Hive. Then you just close the tag, and that's it. Once you are done, and then you verify the installation whether you are correct or not. First you start the Hive shell, then you just type Hive over it, then just simply run a Hive QL command, and you check whether the command is running properly or not. If the command is running properly, then you can type show databases, which will currently show the available database present in our system. So this is all about the installation steps of Apache Hive for a Linux operating system. Next we have for is Pig. So let's see first. So installation of Pig, again the first prerequisite belongs is Hadoop should be installed in the system, and Java 8 version should be installed. Once you are done with your prerequisites, again what you have to do is you have to download the latest and stable version of Apache Pig. Now once you are downloading the version, you have to extract the file. So how will you extract the file? The command is tar minus xvf pig minus 0.7 tar.dz minus c opt. Okay, so what is this minus xv and what is this minus xv and f? Minus x is nothing but the file extraction, v is nothing but the verbose mode, and f is nothing but the archive files which you are going to use. Okay, now this particular command pig minus 0.7.0.tar.dz is nothing but the command for extracting all the files, and hyphen opt hyphen is nothing but where you place in the current directory. Your .tar does nothing but it will bundle all the multiple files together. Now once your multiple files are bundled, you have to compress them using the .gz command. Now you have to go to environment variables and do the following changes. These four are the commands you have to by heart and remember. Export pig home hyphen opt pig minus x dot y dot z, where you are just putting the version of the pig, and then you're declaring all the home path and Hadoop home everything. Once you're done, just click on save, and then again open to command line prompt and check for the version. If it is there, it will directly show the version which is available for pig. So this marks the end of installation process of Hive and Pick. Now we'll immediately jump on to module 5. Module 5 mainly deals about all the machine learning algorithms for your big data analytics. So first, before starting with the module, we have some basic definition. What is that? First is artificial intelligence, AI, what is ML and what is deep learning. So artificial intelligence in the field of computer science is mainly focuses of capable of performing tasks that traditionally require the human intelligence. That means with AI you need human intelligence to get a job done. Okay, these tasks include predicting the future outcomes, recognizing visual patterns, understanding and processing the speech, making decisions, and engaging in natural language processing, that is NLP. And also it mimics human cognitive abilities, allowing them to handle complex processes that are typically done by humans, such as problem solving and learning from experience. So when it comes about AI, you have to mention all these points, like what all it is helping us. It is helping me to predict the future outcomes. It is helping to recognize the visual patterns, and then for understanding and processing speech, we are making use of NLP, natural language processing, and also it is able to mimic the human cognitive abilities. Now, how human cognitive abilities? Because we are the complex tasks which are done by the humans is also done with the help of AI as well, such as problem solving and whatever they're learning from their experiences. Next is machine learning. ML is nothing but a subset of AI. Okay, so it mainly involves three main stages. First is collecting the data, analyzing to identify the patterns, and then you're predicting the future outcome. Main stages. First is collecting the data. You are analyzing to identify the patterns, and then you are predicting all the future outcomes based on the patterns. So these are the main three stages. So over the time, what happens is the system, as you are giving more data to it, its performance will improve, and then it will give more accurate and efficient decision. Obviously, because if your data set is very huge, then it will get more improved performance, because they can you can say analyze the patterns more properly and predict the future outcomes with high probability. So this is all about ML. So let's next we have is deep learning. Deep learning is nothing but an advanced approach of machine learning, okay, that uses complex models such as your neural networks, artificial neural networks, that stimulate the human brain's learning process. Okay, so what happens here is we have to analyze the large data sets with multiple layers of information, because I guess you have learned this in your AIML subject also for your fifth semester, where artificial neural networks were starting first with the outer layer, then you had some many intermediate layers, and then you had an inner layer, correct? And in each layer your uh, in each layer some of the other operations was performing, so that you were getting most proper and accurate results there. Fine. So your the task like computer vision, speech recognition, NLP, and bioinformatics, everything comes under deep learning. So deep learning techniques can also produce results that mainly exceed the human level performance, which mainly helps in your AI assisted medical researches, as well as automated translation and many more things. So this is all about the, you can say, the basic definitions of AI, ML, and DL, that is deep learning. So let's see the next topic, that is establishing relationships, outliers, variances, probability distributions, and correlations. So next we have is first what is known as independent variables. Independent variables are those are directly measurable characteristics and are not affected by the other variables. Okay, that is the those variables which are measurable, at the same time they are not affected by the other variables also. For example include the year of sales or the semester of study. The value of independent variable is not dependent on any other variable. That means the which semester you study, for example, that is semester where you study, and the particular sales year is not dependent upon any other you can say uh, column name or variable name. Okay, so this is example of independent variable. Next is dependent variables. That means the name only says, and they represent characteristics that are influenced by the independent variables only. That means it will depend upon the value of independent variable. Very important, the value of dependent will depend upon the independent variable. For example, profit over successive years or grades avoided in successive semesters are dependent on other factors. For example, successive semester, you can say the grades awarded in successive semester dependent upon other factors. Yes, we can make sure like how corrections have been done. So one factor is depending upon the other factor. So yes, we have a dependent variable here. Next is predictor variable. What is predictor variable? This is an independent variable only that helps to predict the value of a dependent variable. Okay, that means with the independent variable, we are predicting a value of a dependent variable using an equation, function, or a graph. Fine. For example, the sales growth of a car after 5 years from the past sales data. So we are taking a past sales in data set information, and then you are trying to predict a particular income, you can say. Fine. Next you have is outcome variable. Outcome variable is nothing but the effect of manipulations. These represent the effect of manipulation using a function, equation, or experiment. That means the variable which you get after you try to do some experiment kind of thing. For example, CGPA of a student is an outcome variable that depends upon the grades avoided in the semesters. Whatever SGPA you have got in all the 6 semesters as of now is nothing but your cumulatively you can get your CGPA. That is nothing but your outcome. Next is explanatory variable. Your explanatory variable mainly explains the behavior of the dependent variable. How will you explain the behavior dependent variable? For example, your factors which influences the growth and the amount of investment. Okay, that means you can say how an independent variable mainly explains how the growth of a dependent variable is happening. This is explanatory variable. Next is response variable. What is response variable? The a dependent variable that is the focus of a study, experiment, or a computation. It is used to measure the effect of changes or intervention, such as improvement in profits due to investment in class performance due to extra teaching efforts. Response variable in the sense of how will you say it? Like since the name says response, how you can say what changes or you can say what all changes has been made till now in the particular variable so that we are getting a much more improved result. Okay, this is known as response variable. Next is feature variable. Feature variable, the name only says where the characteristics of particular object you are getting in the form of categorical or numerical forms. Okay, now feature variable in the sense can be represented by the categories like red, pink, or yellow. These are the features. Next is categorical variable. The categorical variable, they mainly represent a categories or a group. For example, if you take the different types of car, okay, for example, Maruti Suzuki, Hyundai, or any Swift or Desire kind of thing. So these are all the types of different categories of car, and they will come under the categorical variable, that is car. Okay, all are four-wheeler automobiles. So this mainly covers the different types of variable. Next, you have the relationship using the graphs, scatter plots, and charts. So what the graphs, scatter plots, and charts are mainly used to visualize the relationship. They are all related with your visualization technique. Peace. Then, between visualize the relationship between the quantitative variables. The independent variables are plotted in the x-axis, and dependent variables are mainly plotted on the y-axis. That means you have to remember all the in the x-axis all independent variables, and all the on the y-axis we have all the dependent variables. Now, a line graph can also be uses a line on the xy axis to represent a continuous function showing how dependent variable changes as the independent variable changes. That means dependent totally depends on independent. Piece. That means it is showing that once you are trying to plot a graph of continuous function, the dependent variable changes as soon as you change the independent variable. Next is scatter plot. Scatter plot mainly again type of graph only which uses dots or specific shapes to represent a particular independent variable and the relationship. Next is linear relationship and non-linear relationship. Linear relationship exists between two variables when the data points can be approximated by a straight line which is mathematically expressed as y is equal to a naught plus a1 into xy, that is y is equal to a naught plus ax. Okay, this is the formula for that. The value of A1 represents the linearity coefficient and indicates the strength and direction of the relationship. If the scatter plot shows the pattern that approximates a straight line, it indicates a linear relationship. That is nothing but your A0 is nothing, or you can say A1x. The A1 is your linearity coefficient, which is nothing but which indicates the strength as well as coefficient. Okay. Next we have is the positive linear relationship, negative linear relationship, then perfect strong and weak linear relationship. Your positive linear relationship means that one variable increases, the other should also increase. That means for example, number of students are opting for computer science courses may increase over years. That means when the years are increasing, the students should also increase. Correct? A negative relationship means that if one variable increases, the other should decrease. At the same time, the strength of a relationship can be either perfect, strong, or weak depending upon how close the data points lie on the line. See, and this is the graph of the students. Like for example, the years that keep on increasing: 2000, 2005, 2010, 2015, 20. The number of students are also increasing. So this is nothing but your positive linear relationship. Okay, this is done. Now next you have is the nonlinear relationship. The nonlinear relationship exists when data points cannot be fitted within a straight line but can be fitted within a curve. That means in nonlinear relationship you are getting a curve but not a straight line as that of a linear relationship. Okay, so what is the equation for that? It is y is equal to a naught plus a1x plus a1x1 plus a2x2 up to an xn. Okay guys, remember the formulas, because whenever definition asks, you have to mention the formulas definition along with the diagram, then only you get the marks or it's gone. Next we have the this one. What do you say? An example of nonlinear relationship with the area of the square in relation to length of its side is taken. So what we have done is, like, length of the side of the square, then the area of the square. It shows that once you are taking the length of the side and you are trying to apply the area of square, you won't the all the points will not lie on the straight line. You can see one curve you are getting. Okay, that means it's not occurring on the straight line but a curved line you are getting for nonlinear relationship. This is done. Next you have is outliers. What are outliers? Outliers are nothing but they are the data points that deviate significantly from the other data point in a data set. That means outliers are nothing but a range, you can say. Fine. They are numerically far distant from the set of points and they can indicate anomalous situation or errors. That means outliers is not required or not good for the data. We have to remove it. That means they cause errors. Okay. So what are the anomalous reasons? You can say first is anomalous situation where you unexpected or rare events deviate from the norm. Next is presence of previously unknown facts, where there can be many ranges of data which is not required as such. So you just remove it off. Not required. Next is human error. What if mistakes made during the entry or collection? So what if the user is if user is doing a data entry, if in case he gives a wrong input or something, then there is a wrong in the outlier. Okay, next is participants intentionally reporting to incorrect data. That means this can occur in self-reported measures, especially when sensitive information is there, and also sometimes sampling error also happens. Next is variance. Variance measures the degree to which data points in a data set vary from expected or average value. Important definition. Okay, it is calculated as the sum of the squared differences between each data point and the mean. A high variance indicates data points are spread out, whereas a low variance indicates data points are close to the mean. Okay, so next is standard deviation. Standard deviation is nothing but the square root of the variance. It mainly measures the distance, average distance the data points fall from the mean. So this is the main formula. You have to remember this. S equal to under root of summation of xi. Xi is nothing but from the range of data points. You can say each data point, minus mu is nothing but the mean, and n is nothing but the number of data points. So S is standard deviation, xi is the each data point, m is the mean, and not m, it should be mu. Okay, n is the number of data points. Next is the standard error. Obviously, when you are to calculate the accuracy of predictions made by a relationship, you have to check whether how standard is the error, or what is the formula to check the standard error. The formula to check standard error is S estimate equal to under root of summation of yi minus y cap square by n, where yi is the observed value which you are getting, yi cap is the predicted value, and n is the number of observations. Okay, next you have is the probabilistic distribution of variables, items, and entities. So what happens here is you are doing a probability distribution where probability is nothing but the chance of an event of occurring based on a condition. Okay, so probability distribution is the distribution of the probability values which is denoted by P of X for all the possible outcomes. So probability distribution mainly happens for a given variable X. The probability distribution P of X gives the likelihood of each possible value of X. We will see this in naive Bayes algorithm, which is later in this module. So first you have is a discrete probability distribution. Next is continuous probability distribution. Your discrete probability distribution mainly uses all the discrete variables, for example, rolling of a die, and continuous probability distribution mainly make use of continuous variables like height, weight, etc. So if you see the graph, there is a bell-shaped graph you are obtaining. Okay, and the standard normal distribution has a mean of 0 and a mean of 0 and SD of 1, which is given by the formula P of X equal to 1 by under root 2 pi e to the power of minus x square by 2. This is nothing but the entire probability distribution curve. We have to mention this bell-shaped curve here. Please. Next we have is analysis of variance, next ANOVA. So analysis of variance is nothing but a statistical method to determine whether there are any statistically significant differences between the means of three or more independent groups. It is used to test the null hypothesis and also which assumes that there is no significant difference exists between the groups being compared. In contrast, the alternative hypothesis suggests that there is a significant difference between the groups. So ANOVA and all with all theoretical topics, just mark up the definition and go and write in the exam. Next is null hypothesis. Null hypothesis assumes that there is no significant difference between the means of the group being tested. For example, in case of yearly sales for Tata Zest and Jaguar Land Rover models, the null hypothesis would assume that there is no significant difference in the sales of both the models. And also ANOVA helped me to accept or reject the hypothesis based upon the statistical evidence. Okay, next is F-test. F-test is nothing but where you compare the variance between the two groups, and it mainly it estimate the two population variance. First is the E1V and next is E2V, that is variance between the groups and variance within the group. The variance between the group estimates how much the group means how much the group mean deviate from the overall mean. Okay, and variance within the group, it estimates how much data points within each group deviate from the respective group mean. So F is equal to E1V by E2V, where E1V is nothing but the estimate of variance between the group and E2V is nothing but the estimate of variance within the group. One is between, one is within. Next is F distribution critical value. Your F distribution table is nothing but where you are taking a table to get the you can say get the critical value from a F distribution table, which again depends upon the degree of freedom. And for both numerator as well as denominator, numerator is from between group variance and denominator is within the group variance. And if the calculated F value, whatever you calculate, is greater than the critical value, then null hypothesis is rejected or else it is accepted. Okay. Correlation next. Correlation is mainly measures the strength and direction of relationship between the two variables. So it mainly quantifies how one variable changes with respect to another. So it is mainly denoted by R square. So R square is a statistical measure used to evaluate the goodness of fit in a regression model, and it is also known as coefficient of determination. Coefficient determination is nothing but it represents the proportion of the variance in the dependent variable that can be explained by the independent model. Okay, and R square is also known as the Pearson's correlation coefficient, which again ranges from 0 to 1. So if R, this is R square, not R2 guys. Okay, R square equal to 1, that means it's a perfect fit where the predicted values are identical to the observed value, and R square equal to 0 means no correlation between the model and the observed data, and larger the R square values indicate a better model fit. That means you have very strong correlation. So mainly correlation is nothing but it measures the strength and direction of relationship between the two variables, and it is mainly calculated by R square. R square is nothing but your coefficient of determination or the Pearson's correlation coefficient, and for interpretation it is mainly we check whether R square equal to 1. If it is equal to 1, then it's a perfect fit, and if it is 0, then it is a It has no correlation. That's it. Next is regression analysis. Regression analysis is again a statistical method to estimate the relationship among the different variables. Now, it mainly helps us to know how the dependent variable changes when one or more independent variables are modified. For example, x is there, y is there, x is dependent, y is independent. X is totally dependent on y. Now, if y value changes, how the value of x also gets changed is all about regression analysis. The main goal of regression analysis is nothing but to establish or to model the relationship to make predictions about the future of the dependent variable. That means how the value of x will get changed in future when y is getting changed is all about the regression analysis. That is my main goal. Next you have is the multivariate distribution. Multivariate distribution where multiple variables are mainly involved. For example, you can say if a company wants to predict the future sales of Jaguar cars based upon the past sales data, it would analyze the relationship between the sales of previous years and the sale of current year. That means if I consider this as one variable, dependent variable, and again sales as also dependent variable, then how you can determine the, you can say the future sales. That means, sorry, this is independent, not dependent. Independent. Now since your sale of current of today's sale of Jaguar cars will depend upon the previous sale as well as the current sale. So today is nothing but dependent, it will how it is today's is dependent, how it is dependent upon the independent variables. Okay, next is the regression analysis. Regression analysis mainly establishes relationship how one or more independent variables influence the dependent variable. Let's see the formulas. First we have this non-linear regression. Non-linear regression is mainly something where the graph you obtain is not linear. Okay, again it establishes relationship between the independent as well as dependent variable. Now general equation is mainly consist of multiple terms like y equal to a1 x1 plus a2 x2 up to, it goes on up to a and xn. Okay, where y is the dependent variable and your x1 x2 x3 x4 all are your independent variables. That means y is dependent on x and x is independent of y. Okay, linear regression, again the same thing, only you get a straight line here. This is already done. And simple linear regression is mainly explained with the help of this formula y equal to mx plus c. Let's see the definition. Simple linear regression is most commonly used term for regression analysis. It is mainly a supervised machine learning algorithm which mainly predicts the value of a dependent variable using one independent variable. So using one independent variable, you are just predicting the value of a dependent variable, and it is a supervised algorithm. Okay, it makes use of independent variable x and dependent variable y. There was a printing mistake and that's why it came like this. I'm sorry for that. Next we have is the key feature. The main objective of is to fit a line, that is data regression line, that minimizes the deviation from all the points. Then deviation from the line is known as error. For example, if a point is lying away from the straight line, so it's nothing but error itself. So what is the equation? Y equal to mx plus c. Y is a dependent variable, x is the independent variable, your m is nothing but the slope of the line, and c is nothing but the intercept. Okay, what is the objective of simple linear regression? My objective is the best fitting line I'll get from this, and also it will minimize my error. Okay, that is all about the simple linear regression. Next to have is the what are the steps of performing the simple linear regression. Guys, these are nothing but you have studied in your AIML subject in 5th semester. Also, if you had maths till 4th sem, all these things are known to you. Still, again, it's a revision or brush up, I would say. First step is collect the data. Collect the data, how will you do? Gather the data for both the independent as well as dependent variables. Then you fit a line. Use statistical methods like least square method to fit the line that minimizes the error. Because at the end, my error should be minimum. Okay. Then we have a predict. Predict, what we will do is once the regression line is obtained, we can predict the value of y using the value of x. Then evaluate the model. How will you evaluate the model? By using R square method as well as mean square method, mean square error. Okay, done. Next is multiple regression. For multiple regression, again, what you do is it's an extension of the simple linear regression model where you're making use of criterion variable, that is nothing but the dependent variable, using two or more predictor independent variable. That means here what you are getting is the number of independent variables are more, okay, and there is one criterion variable known as the dependent variable. Fine. So multiple regression, what will do is it will take multiple independent variables simultaneously, making it more complex scenarios. Okay, that means results sometimes are more complex, and it all deals with all the real world scenarios. If you see, everyone deals with the multiple regression. So what are the you can say the real world application or the use cases of multiple regression? First is real world scenarios where where you are depicting or you are seeing the company sales and predicting an outcome. Next is forecasting and prediction, that is nothing but your weather forecast. What is the general formula for this? Y equal to b naught plus b1 x1 plus b2 x2 up to bn xn plus epsilon. Your y is nothing but the dependent variable, b naught is nothing but the intercept, b1 b2 up to bn are the regression coefficients for the independent variable. Okay, regression coefficient, and epsilon is nothing but the error term. Next, what is the application? Again, sales forecasting, already mentioned above. Marketing analysis, you can do it. Then risk management in finance, where multiple regression models can be used to minimize the risk of, you can say, loan defaults and everything. Okay, then employment discrimination, where multiple you can say regression analysis can be used in various factors, where job role, education, then experience to determine if a gender is significant for salary discrepancies. Means you can say it is mainly used whether a male candidate should be paid more or female candidate should be paid more or less. So it's mainly used in employment discrimination. Next is real estate price and prediction, again for estimating the price of a particular product. Biological activity prediction, for in the sense to predict the, you can say, the structure of any protein or any drug or discovery. Next you have is prediction of parental characteristics, in the sense like uh, to identify yourself based on your academics performance or your education level, your lifestyle and income. Fine. Now next we have is the advantages. What are the advantages of this? Advantages we have is first is multiple predictors, better accuracy and interaction effects. The multiple predictors is mainly, you can say, can handle more than one independent variable, allowing a more comprehensive analysis of the dependent variable. Because obviously your dependent variable is depending on the independent variable. The more the number of independent variables, the more better is the performance. Next is better accuracy. Same thing, better accuracy. How? Because you are getting multiple regression models, and again in complex environment, it will give you much more proper results. Next we have is the interaction effects. Interaction effects, what happens is like you can establish or you can interact with the different predictor variables, because we have seen the formula here, y equal to b naught b1 x1 b2 x2 bn xn. We had some you can say we had many independent variables, we had one you can say criterion variable and all. So that's all about this. Next we have is interaction effect. Yeah, this is important when combined effect of two or more predictors is significant for individual effect. That means there might be some scenario where different combiners were interacting to determine a value of a particular variable. So in that case, multiple regression comes into a picture. Mining. So what is text mining? Text mining is nothing but the process of extracting valuable knowledge, insights and patterns from large collections of textual data. So you are having a large collection of text data, and you are gaining some valuable knowledge and insights from that. So how you are getting that is mainly this involves analyzing the text data in a very structured or unstructured form, and it is used to uncover the patterns, relationship and insight that may not be immediately apparent. So let's discuss about everything in detail. With the rise of social media, user-generated content such as text messages and videos have increased exponentially. Text mining plays a crucial role in analyzing and understanding this vast amount of data for actionable insights across various domains. That means as the days are going on, we are generating like a lot amount of textual data is generated from social media, like text, images and videos, and for analyzing the domain, for analyzing their patterns and all, we are going to perform text mining. Okay, so what are the text mining applications? Let's see. Like it is a mainly it is used in your decision support, sentiment analysis, fraud detection, survey analysis, and many more things. So first we have is marketing. Okay, so in marketing, in customer voice analysis, what they do is text mining can help to capture and analyze the raw customer feedback from the social media to understand the customer preferences and the complaints. Whatever is nothing but your like your Google Forms kind of thing where you give feedback. Okay, so it helps you to understand customer preferences and complaints. For example, after every semester, you get your feedback form to fill the feedback of how every subject was being taught in the semester. So depending upon how you give the feedback, the very next semester they will uh, the teachers who are teaching the subject, they will do their improvements to how to make the subjects better. Okay, there's nothing but your analysis part. Next is persons and segmentation. It mainly helps in analyzing social media content, review blogs and tweets. They are mainly these inputs provide indicators that can help anticipate customers behavior as well as preferences. Next is listening platform. A listening platform is nothing but a tool which analyzes the real-time data from social media, blogs, and textual feedback. What it will do is it will extract all the meaningful insights such as customer sentiment, which will help them to improve the product and customer service strategies. Next is customer support. In customer support, what you are doing is where the text mining is helped to you can say identify the common patterns in customer complaints. So techniques like your decision trees will help you to organize this data, allowing business to proactively address potential issues in a product management and customer service. Okay, next is business operation. In your business operation, again, it helps in sentimental analysis for applied to email, blogs, and social media content. Then you have its investment and financial insights. Investment financial insight, again, the same thing, like by analyzing the social media, investors may gain insight that can lead to better decision making and superior investment returns. Next is legal search. In legal search, what happens is again when you are trying to access databases of legal documents, case histories, and laws, it mainly helps you in this text mining will help you to find relevant documents quickly, improving the efficiency and effectiveness of the research. Okay. Next, we have e-discovery. E-discovery platforms are also uses text mining, which help organizations to minimize the risk associated with the sharing the legally mandated documents. Next is predictive legal insights. Predictive legal insights in the sense the testimonies, the case histories, and the client meeting notes, whatever it is happening, like all the private information, everything. You can say text mining is one of the most important method to uh, do the analysis. Okay. Next is governance and policies. Governance policies against social media and public sentiment for across all the social media platforms. Micro targeting in elections. In elections also how campaigns are arranged, and these campaigns mainly use resources and they reach the voters to meet the specific concerns. Next is geopolitical security. In geopolitical security, what happens is you are detecting the emerging threats and crises. Fine. Next is research and analysis. Research and analysis in academic research. The you can say text mining mainly helps to analyze large amount of research papers and publications to find the emerging trends. Now, what is the text mining process? Text mining process again it involves a flow chart where the you can say some five phases are there. First is text pre-processing. Next is feature generation. Followed by that we have feature selection, data mining, and analyzing results. So the first phase mainly starts with text pre-processing. It's nothing but where you are enabling the effective syntactic and the semantic analysis of the text. Now what is semantic analysis? Let's deal in detail. First is text cleanup. We have to clean up certain unwanted text or the text which are totally irrelevant and not required. So how we are trying to remove it is first you are filling in the missing values. If any missing values are present, you try to fill them up. Next is removing the outliers and consistencies. If you have any outliers, for example, if any range of data which is not required or any inconsistent data is there, just simply remove it off. Or some spelling mistakes, for example, typographical errors. For example, the THE is now spelled as TEH. So again, you have to remove all those things. Or if any URL is present, you just remove it off. Next is tokenization. In tokenization, what happens is you are just splitting the clean text from this first step to individual tokens using white space and punctuation mark as your delimiters. Like for example, some text is there. You are first cleaning it up, like removing all the missing values, and then you are putting all the white space and punctuation marks. Once you're done with this, you are doing a POS tagging. The POS tagging is nothing but the part of speech. Like Each word is tagged with its part of speech such as noun, verb, or adjective. For example, dog is might be tagged as a noun and run as a verb. Okay. Then word sense disambiguation in the sense like this method identifies the correct meaning of a word based on the context. For example, bank could be referred as a financial institution also. For example, or your bank and all, SBI, HDFC, everything, or the side of a river is also known as a bank. So sometimes disambiguation may occur, so make sure that the correct meaning of the word is always taken out from the context. Next is parsing. In parsing, what happens is you're generating a parse tree for each sentences to analyze the grammatical structure and relationship. So this is all about the first step of text preprocessing. In text preprocessing, what you are doing is you're cleaning the text, you're performing tokenization, you are doing part of speech. Once you're done with part of speech, you are sensing the word discrimination. For example, same words, different meaning, and next we're doing is parsing, generating parse tree and all. Next is features generation. Features generation is again created for the further analysis you do. The goal is to represent a text in a way that machine learning algorithms can process. First is bag of words. A bag of words mainly represents a document as a collection of words ignoring the order. Okay, now what happens here is you are calculating the frequency of each word in the document before applying the classification or clustering algorithms. Next is stemming. Stemming is nothing but you are just reducing the words to its root word. What is root word? For example, running is will be set to run. Okay, sleeping to sleep. The root word you are just taking it. Okay, just removing the ing form and just taking the root word. Removing stop words. Removing stop words in the sense many words such as your a, at, for, and the are removed because they typically don't contribute any meaningful contribution. Obviously, these are articles and all articles prepositions. They don't contribute to any of the meaningful information there. Then you have as a vector space model. Vector space model mainly represents the text documents as vectors or frequencies. The TF-IDF, that is the term frequency inverse document frequency method, is mainly used to evaluate the, you can say, performance of, not performance, the importance of each word in the document collection. Next is feature selection. Feature generation is there. Once you generate the features, next is feature selection. In feature selection, what you are doing is now you are applying dimension reduction algorithm like your PCA, component analysis, or your LDA. What it will do is it will help you to reduce the higher dimension data set into lower dimension, thus making the model more efficient. Okay, next is n-gram evaluation. N-gram evaluation, what you are doing is it is mainly extract meaningful words combination from the text. And next is noise detection. Noise detection, for example, if any unusual or irrelevant data is there, then you just remove it off. Fine, not required. Phase 4 you have is data mining techniques. In data mining techniques, what happens is first you are applying the, now you are applying all the machine learning algorithm. First you have is clustering. Unsupervised learning, the labels are not known and the goal is to discover the clusters or groups within the data. For example, what you are doing is you're grouping the similar documents together based upon the content. If two or more documents are having the same content, you are just grouping them off as a one cluster. Next is classification. Classification, what you are doing is now the data is labeled and now the model is trained to classify the new data. For example, you can do the spam email classification as well as your sentimental analysis. Next is evolutionary pattern identification. Evolutionary pattern identification mainly analyzes your new articles and summarize the events in the recent future. Next is analyzing the result, phase 5. So in phase 5, what happens is you are evaluating the outcome, like what outcome did you determine, whether you meet the objectives or not. Next is interpretation of results. We are seeing like yes, whether the results are acceptable or not, or hence we have to repeat the algorithm again. Visualization, again data is visualized with the help of graphs, charts, etc. to understand the findings. And next is further improvement, how you can improve the same project again and again to improve the business process and strategies. Next is text mining challenges. Now, what are the challenges faced in text mining? First is NLP, natural language processing issues. Okay, so in POS tagging, that is the first stage. What happens is part of speech tagging, identifying the correct speech for a word in a sentence sometimes can be very difficult. Okay, especially when same words will have multiple meanings. Okay, so in that case, you say POS tagging is not a good option there. Next is ambiguity. Ambiguity in the sense that multiple meanings can be derived from the same context. For example, you can say the word bat, again it is a flying mammal, or it can be a sports equipment. Next is tokenization. Tokenization, again the splitting up of text into smaller tokens or phrases. Sometimes uh, Tokenization will not be possible for your compound words or your you can say the large sentences or punctuation. You can't do that. Next is parsing. It mainly what happens is sometimes due to complexity of the sentence or the structure is not good, you can't get the proper parse tree and the grammar there. So again, parsing is a very difficult job. Stemming in the sense like sometimes the root word is not available, so stemming is not an option. For example, like running, the root word was run, but for better, what will you put? Not bet, correct. So one is this will go wrong. Next is synonymy and polysemy. Synonymy is nothing but challenge of identifying the similar words where you are car and automobile both of the same thing. Whereas your polysemy is nothing where multiple meanings will be there, and they might confuse my system. For example, bank is also denotes the you can say financial institution. For example, your government banks to the private bank, or it may denote the side of a river. Next is mining challenges. Mining challenges in the same time, identification of suitable algorithm. You don't know which algorithm to choose, whether a classification or a clustering. Next is massive amounts of data. Sometimes large amounts of data are generated, so you can say text mining is a very difficult task to perform. Next is semantic relation. So what happens is again the previous one only, extracting meaningful concepts and understanding the relationship between them, sometimes very complex. Next is when no training data is available, developing models without them reduces the performance of the system. Next you have is the variety of data. Variety of data is like how the data you have taking it from, what are the sources, whether it's social media, scientific articles, news or textbooks. So different preprocessing techniques are there for the different varieties of data. Next is unstructured language. Many of the text data is mainly unstructured, mainly that doesn't have any proper predefined format. So it's a very difficult to process them. Next is individual information visualization. Like once insights are extracted, you are presenting them in a way is a very much challenge. So visualization tools must be available to make sure that yes, you are making actionable insight. Next is real-time text streams. Again, traditional batch processing methods is not suitable for real-time scenarios, whereas you can say text mining, we can do it. Next is scalability. Text mining system must be scalable to handle the large volumes of data, again to maintain the performance and efficiency of the system. So how will you improve the text mining processes? Text mining process is again is a powerful tool for extracting the textual data. First, you always ask the right question. The first and most critical practice in text mining is to define the problem clearly before you start the operation. Okay, the question should be well defined, actionable and capable of producing the result. Then next is be creative and open in proposing hypothesis. For example, creativity is a vital in text mining as it uncover valuable insights that traditional methods might miss. For example, you should be very much creative in whatever the text mining is you want to perform. For example, encourage the outside box thinking when formulating the hypothesis. You make sure of different, you can say, tools and strategies for uh, creating the, you can say, the text mining process, and so that you get the most proper and accurate result. Next is pursue the problem iteratively. That is, text mining often involves large complex data sets, so it is crucial to for us to divide the problem into smaller steps and then you start working with the process. Next is make use of variety of data mining tools. Data mining tools are available, so make sure you use all those tools and discover the meaningful insights. So text mining is also one of the very much important question for your externals. They might come for 10 marks directly, so you have to explain all these things. Next is data mining versus text mining difference. Data mining is nothing but a statistical technique of processing the raw data in a structured form, whereas your text mining is nothing but it's a part of data mining which involves processing of text. Okay, here you have pre-existing databases and spreadsheets, but uh, your text mining doesn't have any data set present. You already gain the high quality information there only. Here processing of data is done directly. Here it is done linguistically. You have statistical methods to evaluate the data. Here again you have algorithms to compute. Okay, now data mining, data is in structured format. Here it is in unstructured format. Data is homogeneous. Here it is heterogeneous. It supports mining of mixed data. In text mining, only mining of text is done. Okay, it combines with AI, ML and statistics, and it involves only NLP to recognize. Okay, it is used in fields like marketing, medicine and healthcare. It is mainly using customer profile analysis. Web mining is nothing but the process of discovering patterns and insights from the data present on the World Wide Web to enhance web and improve the user experience. That means you are just discovering patterns and insights from the data which you are getting it from the web, and nothing, you are just improving the user experience. So as the web grows exponentially, more and more data is being generated daily, and now you can say web mining becomes a very crucial tool for understanding and for optimizing how the internet is being used. Okay, so web serves functions including electronic commerce, business communication, social interaction, which makes it essential to extract valuable insights from the web data. So web mining collects data through web crawlers, web blogs, and other means, helping to uncover the trends that can optimize the content, improve the user experiences, and provide the business insights. Okay, so next is characteristics for optimized websites. For a website to be considered optimized, it needs to have several characteristics. Three of the main is appearance, content, as well as functionality. Appearance means the first word only says aesthetic design. It has to be aesthetic. Okay, the design of a website plays a significant role in a user's engagement. Then it encourages, like, it captures attention and it encourages the interaction. Okay, now well formatted content, it should be, and the content should be easy to read, scannable, as well as logically structured to enhance the user experience. Then easy navigation, in the sense it should have pathways to ensure that users can find information whatever they are looking for it, and also good color contrast, nothing but you should have a very good front end which enhances the visual appeal of the website. Next is content. Content, in the sense, like, the content should be structured logically and organized in a way that should be that is needed for the user. Next is fresh content. What is fresh content? Regularly you should update the content such that you get the latest information of a particular source. Then search engine optimization. Optimize the content for search engines, making it more discoverable and driving organic traffic to the site. For means that you should be optimizing the search engine such that you, whatever you are searching for, you get the result immediately rather than waiting for a long period of time. Links to other good sites. Having high quality external links may help to build authority and offer additional value to the users. Next is functionality. Functionality, in the sense, the accessibility for the authorized users, like they should get all the accesses over the internet. Next is fast loading time. A website should load quickly to reduce the frustration level for the user. Usable forms. User friendly forms should be there, and you can say some sign up forms to improve the interaction rates. And mobile enabled, in the sense that whatever responsive website which you are making should be also be deployed the same into an app. Okay, what is the web mining structure? We have web mining, followed by that we have a web content, which is nothing but the HTML content, then a web structure and a web usage. Okay, this is the web mining structure. So let's see the next part. Now web content mining. So web content mining mainly focuses on extracting the useful information from the web pages, which mainly includes your text, images, and other media. The websites are mainly organized into pages where each page is linked with a URL, and these pages are managed by the content management system. Okay, now the web content mining mainly helps in analyzing the content of these pages and gain the insight and user experiences. First and foremost, we have the text analysis. Text analysis mainly help you to examine the textual content of the web, whatever text content is present. Okay, this may include the frequency of specific terms, content sentiment, as well as user generated content. Next is the application content. Application content, in the sense, like, interactive elements like your forms, user interactions, and applications on the web pages, focusing how they contribute to the user engagement and the conversion rates. Next is popularity analysis. Popularity analysis mainly helps to optimize and update the most visited pages to keep them fresh and engaging. Content quality evaluation, in the sense, like, high quality, you can say, information should be there, or else it mainly reduces the, you can say, the number of users who will be visiting that website. Next is web structure mining. Web structure mining mainly involves analyzing the structure of web pages, focusing primarily on the hyperlinks between them, because in a website one page is linked to one another through a hyperlink, correct? And the interconnected nature of the web, where pages linked to one another, often uh, offers a rich source of information. So what are the two key models of web structure mining? First is hub, next is authority. Hub is nothing but a web pages with numerous outgoing links to the other pages. Okay, they mainly serve as central points that direct users to a wide variety of information. For example, your government website, what happens is these pages mainly act as hub, which mainly gather information from other sources and directs user to different areas of interest. Next is authorities. Authorities nothing but they are seen as authoritative on a specific topic, and they have numerous inbound links from other web pages. For example, in one web page you will have one another inbound link present. With that inbound link, what you can do is you can navigate to other, you can say, web page. Okay. Now next, for example, you have is the myoclinic.com for medical information, nytimes.com for the daily news. Next is web usage mining. Web usage mining is nothing but the process of extracting useful patterns and insight from data generated by the user in a website. Okay, now it mainly includes tracking of clicks, how many clicks you have done, page views, how many views have gone to the particular page, and what all actions you have performed on the web server. Everything comes under web usage mining. First is clickstream analysis. Clickstream analysis mainly analyze the sequence of clicks made by the user as they navigate to the website from 1 to 2, 2 to 3, 3 to 4, like that way. Okay, so by examining the pattern, this pattern, what will happen is you can come to know about the popular pages, the user behavior, and the bottlenecks in the navigation. For example, if any network congestion happens, you will easily get to know about it. It is also seen in market research, software testing, as well as employee productivity analysis. Next is user profile and behavioral analysis. What happens is here you can easily get to know about the user profiles based upon the browsing history. What all things they have browsed, you can easily come to know about it. Then textual information mining. Textual information mining mainly it is deals with techniques like bag of words, which is built on a document matrix. With that, you are able to identify the popular topics, user interest, as well as sentimental trends. But the applications now, applications mainly use predicting the user behavior. For users click stream and data profiles, you get to know about the future actions. Customer segmentation and targeting mainly segments users into groups based on browsing patterns. Evaluating promotional campaigns, which mainly measure the success of marketing campaigns by analyzing the user engagement. Next, you have is dynamic content delivery, where you are based on the user profile. What you are doing is you can present dynamic personalized content and advertisement as well. This marks the end of the web mining. So this is the web mining architecture. First, you have is website visitors, users, and customers for a website. Let's see. Then you have number of click streams there. Once you get the number of click stream, then you get the then you gather and prepare the data for analysis. One second. Yeah, you get the data for the analysis. Then you find all the patterns, user profiles, and the web piece. Then next you have is your naive Bayes algorithm. Naive Bayes is nothing but a supervised machine learning algorithm, which is mainly based on the probability theory. Okay. It predicts the probability of an instance belonging to a specific class given prior probabilities and the predictors. So what is my formula? P C upon X is equal to P of X upon C into P of C upon P of X. So we have, this is nothing but your posterior probability, which mainly uh, helps the probability of class C. The class C is nothing but the target given that the predictor is X. Okay, now P of C is nothing but the prior probability, that is the initial probability of the class before observing any predictors. Then P of X upon C, this one is nothing but the predictor of X given class C. Then next we have its predictor probability itself, that is P of X. So you have to remember this formulas. So that is all about naive Bayes, where you know about posterior probability, prior probability, likelihood, and predictor probability. You have to remember all these four terms: posterior, prior, likelihood, predictor. Advantages you have is first efficiency, then simplicity. In efficiency, what you are doing is, again, it requires a minimal training of data is required for estimating the test data, and also it performs well when the assumption of the independent, you can say, predictors are okay. Then what are the disadvantages? Disadvantages in the sense, naive Bayes assume that all predictors are independent, but sometimes this is not true. Also, what happens is zero frequency use. If a category in the test dataset does not appear, for example, you get a value which is not appearing in the dataset, then you get zero frequency issue, where it can be solved using smoothing techniques like Laplace estimation. Then you have the practical application, where it is mainly used in spam detection and sentimental analysis and text classification for your naive Bayes algorithm. Next is your support vector machines, SVM. SVM is nothing but it's a supervised machine learning algorithm mainly used for classification as well as regression problems, but we have more focus on classification task itself. The mainly algorithm represents data points in an n-dimensional space where your n is nothing but the number of features, and it identifies the optimal hyperplane that distinguish between the classes. There is an optimal hyperplane which is obtained in a graph, and it mainly helps to distinguish between the two classes which are lying across the hyperplane. So how does it work? First, you have a data representation where each data is mainly plotted onto a two-dimensional space with its coordinates. Next is hyperplane identification, where you are finding a hyperplane that will separate my two classes. Next is margin maximization. The margin maximization is nothing but the margin is the distance between the hyperplane and the nearest data point from the each class. We'll see the diagram here. See, this is the diagram for SVM. We have the points here. This is the optimized hyperplane. Okay, now this and this are the nearest points present. So this is nothing but the distance between this point and this point, nothing but the maximized origin. Now these are nothing but the two different support vectors of different classes. This is class 1, this is class 2. Two are separated by a optimal hyperplane. Now next, see the advantages. We have high dimensional feature space. Mainly you can say SVM can mainly perform high dimensional data processing. Next is non-linear decision boundaries, in the sense like it can handle the non-linear decision boundaries by transforming them into higher dimensions. Higher dimension in the sense you are making use of kernels and all, but the classifier can be represented as a linear function. Next is ease of understanding. Ease of understanding, which is very simple actually to implement. Efficiency, it provides more computation. The process is very much efficient, and wide availability in the sense like a large number of data analytics and machine learning toolsets work on SVM. What are the disadvantages? First is numeric input requirement. You have to, the dimensions has to be numeric in nature. Okay, next is binary classification. Binary classification you can't do SVM. Next is computational complexity, like training the SVM sometimes is inefficient, so it becomes complex. Next is noise sensitivity. Noise sensitivity, mainly it has a noisy data which will give you problem, and a lack of probability estimate, in the sense like it will not give the probability estimation or the percentage, like how confident or how correct is the data. It is also used in spam detection for detecting whether a mail is a spam email or a normal email. Next we have is image recognition for classifying the images. Next is text categorization, sorting them in the documents, and bioinformatics for expressing the gene profile. Next we have is PageRank. PageRank is nothing but a link analysis algorithm which was developed by Larry Page and Sergey Brin, used to rank web pages based upon their importance. Okay, so how a PageRank algorithm works? First is each page is assigned with the initial rank, which is usually 1 by n, where n is nothing but total number of pages, and the rank of a page is calculated iteratively based on the ranks of the other linking pages to it. So one page is linked to other page. Depending upon the rank of the other page, you will determine the rank of the current page. Okay, what is the page rank formula now? PR, it is PR of P, it is denoted, that is PR is nothing but the page rank of P, is denoted by 1 minus d upon n plus d into epsilon of q. Q belongs to L of P, PR of Q upon C. Okay, where D is nothing but a damping factor. Typically it is 0.85. It mainly, you can say, accounts for probability of randomly following links versus jumping to a random page, like how you are moving from one page to another page. It's nothing but damping factor. N is nothing but number of pages. L of P is set of pages linking to P, and C of Q is number of outbound links to Q. That means how many links are coming out from that particular page. Okay, next is structure of web. It is web can be represented as a directed graph when nodes represent the web pages and edges represent the hyperlinks between them. For example, A is a web page, B is a web page, and C is a web page. We are denoting it with the directed graph. Okay, so these A, B, C, nothing but the nodes. They are A to B, A to C, and B to C, nothing but the hyperlinks. What are the characteristics? Characteristics mainly depends upon a bow tie structure where a strongly connected pages are mutually reachable. Okay, if the pages are strongly connected, then they are reachable. In links nothing but the pages that link to the core. Outlinks are nothing but which are coming out from the core. Okay, then disconnected components is nothing but the isolated pages or the group of pages which doesn't have any links. For example, I make a page like D and D is not connected to anyone. Small world phenomena, for example, it can also be most pages are sometimes reachable within a small number of clicks also when they have a high clustering coefficient, while some may take a lot of time to load and all. Next is power law distribution. Power law distribution mainly says that smaller number of page will have a high number of links. Next is analyzing a web graph. How will you analyze a web graph now? First is your representation. We may make use of adjacency matrix or adjacency list to represent the graph. Okay. So next is apply the page rank algorithm iteratively. You apply the page rank algorithm depending upon the number of clicks on the next page and the rank of the next page to determine the rank of the current page. Correct. Next is properties in degree, out degree, and connectivity, where you are in degree is nothing but pointing to a edge, whereas out degree is going out from an edge, and connectivity is nothing but strongly connected components. And how we are doing traversal by using your BFS as well as DFS. Now see, you can see a page A, B, C, A, B, C, D, and E. Now first you do is first adjacency matrix. You have to create it whether you seriously have a graph or not. Okay. Then, for example, you already studied in your DS A, B, C, D, E, A, B, C, D, E. Check A to A. Anything is there? No, nothing. Then put 0. A to B, A to B. No, it's not there. Put 0. A to C. Yes, it's there. Put 1. Okay, then A to D, A to D, A to D, no, directly is not there, put 0. A to E, A to E, no, it's not there, put 0. Similarly, fill the adjacency matrix and everything. Okay, then once you are done with this, you just calculate the page. We calculate the page rank depending upon damping factor D, total number of pages of n, and the threshold, and then output will be nothing but the page rank for all the pages. Social network has graph. So what is a social network? Social network can be represented as a graph when nodes are called vertices, which determine the groups or organization which represent the relationship between them. Also, these edges, for example, in social media platform, users can interact, users can represent it as nodes, and the friendship, or you can say how they are linked together, are mainly represented as edges. Analyzing social network using graph theory enables to understand the connectivity, influence, and the overall structure of the network. Social network analysis is also used in study and interpretation of social networks and computational methods. It is mainly used to understand the community structures and uncovering the patterns of interaction between them. Also, using tools like clustering, similarity measures, as well as community detection, what you can do is you are getting much more insightful features from the densely connected communities within the network. Next is clustering. Clustering is nothing but you are grouping the nodes in a network such that nodes within the same cluster are more interconnected than those different clusters. Okay, they are mainly identify communities or subgroups within the network. Then, for example, if you see clustering, main common example will be COVID. A particular region, you can say, you can, but if you see a particular cluster is identified as a COVID region, like in that case, the number of COVID cases are very high. So in that scenario, you can put COVID as an example of clustering. Also, it is mainly, you can say, different methods are there: modularity based, spectral based, hierarchical based clustering. And the quality of the clustering is mainly done by evaluating the number of links which are present in the cluster. Okay. What is SimRank? SimRank is nothing but the similarity measure that evaluates the structural similarity between the two nodes in a graph. The core idea is that two nodes are similar if they're connected to similar nodes. Okay, if two nodes are, if both the nodes are connected together, then they both are similar nodes. For example, in a citation network, two research papers might be considered similar if they are both cited by the same set of papers. Okay. Then sim rank is usually, you can say, starts with the initial score of usually 1, and it is updated based upon the similarity of the neighboring nodes. Next is counting triangles. In counting triangles, what you do is, triangles in social network are mainly formed when three nodes are mutually connected. Obviously, triangle creation, you need three nodes. Correct. So for analyzing the local clustering coefficient, it mainly indicates the likelihood of two neighbors, how this and this are connected. Okay, how A and, this is, suppose I say this is A, this is B, this is C, how A and B is connected, how B and C is connected, how A and C is connected, everything is happening with the help of local clustering coefficient, which will help you to analyze it. Piece. Then you have is the graph matching on the other hand, and graph matching also you can do it where we are just finding the similarity between both the graphs, and it is also used in organizational hierarchies of friend groups, mainly for high dense network structures. You are making use of this. Next is direct discovery of communities. Direct discovery of communities are mainly used to identify the group of node social network that are densely connected but have sparse connections. Okay, techniques such as the Girvan-Newman algorithm, which mainly removes the edges with highest betweenness centrality, mainly maximizes modularity and often used for discovering the community. So two algorithms are there. First is the Girvan-Newman algorithm, and next is the Liouville method. These two methods are mainly used to remove the edges with high betweenness and also used for discovering the communities. Okay, so this was all about direct discovery. Next you have is the application of social network. Application of social network is mainly used in many domains. Its list is only never ending. First is, you can say, for friend and content recommendation, triangle counting, then community detection, also for spreading awareness and all in a particular area or a group. Overall, you can say social network analysis enables business, researchers and organizations to harness the power of network effectively. Next you have is click. Click is nothing but the subset of vertices within a graph that are that every two distinct vertices in the click are adjacent. In other words, it forms a complete subgraph. Okay, so this means that every member of the click is directly connected to other member, and clicks are very much significant because they represent a group of individuals who all know each other. So what is a diagram for this? Very simple diagram you have. For example, this is a node. So this one complete region will form a click, because all the nodes are connected to each other, and this is mainly forms a complete subgraph. So this is all about click. Again, this is again one click one, this is click two. Make sure you are having one subgraph and all the nodes are connected to each other and they know each other. With this, we conclude the module 5 of big data analytics. The notes and everything will be shared in the Google Drive link. You can go and access them, start studying from now onwards. And important questions are already uploaded in the important questions video. You can go and check out in the playlist. Till then, like, share and subscribe. Wish you all the best for big data analytics. Thank you guys.